All right, so I'm going to go ahead and start looking at example 4 now. Again, the only real difference here is I'm using equilateral triangles instead of squares or semicircles, and the only real difference in formulas is that square root of 3 over 4. So the first one had pi over 8 times d, or the diameter squared. The second one was just the side squared. In this case, it's the square root of 3 over 4 times the side squared. I still left most of this work up from the last video just simply because I don't really need to change a whole lot. The only thing I need to change in this case, going from squares to triangles, is putting this square root of 3 over 4 in. So that's all I'm going to do is think about it. In this case, again, what this picture looks like is it's going to have this curved side on the bottom and a straight side. And what we're going to do is we're going to have these pointy equilateral triangles sticking out. Again, the wider the region, the taller the triangles. And so as I get closer toward the ends where it's a little bit skinnier, it's going to have these shorter triangles. And so it's going to kind of look a little bit like a tent, where it's got this kind of ridge to it, and it's going to be higher in the middle and tapers off at the end. And so that's oftentimes what we call things with equilateral triangles as their cross sections. We often call them tents, regardless of what the base looks like. So again, all I need to do is put a square root of 3 over 4 in here. And I could put it on the inside of the integral, but all I'm going to do is take it out anyways. It's a constant. So everything here is going to be the same. The only thing I need to do again is just essentially multiply by the square root of 3 over 4. Because that's all I'm going to do on all of these steps is just keep that square root of 3 over 4 in my brain. Keep it present while I work through these problems. And so if I get down to the answer and I try to do 81 over 10 times the square root of 3 over 4, what that's going to end up giving me is it's going to be 81 times the square root of 3 over 40. And unfortunately, that's not really going to simplify. So again, here's my answer for this question, number 4. It's going to be 81 square roots of 3 over 40. And the one above it, the squares, we said was 81 over 10. So notice, it doesn't really matter so much these formulas because they're all the same. They're all very similar. The only thing that I need to remember is that little bit of extra information at the front. So like I said, the semicircles are pi over 8. For areas that you don't really have to multiply by anything. Equilateral triangles is square root of 3 over 4. Those are the important things because otherwise the work is essentially the same. It only changes based off of what the cross section is. So hopefully this helps you understand a little bit more about why we did things in the order we did them. Again, the first thing we did, we paid attention to what the area of the base was. And we did that by looking at the graph and working it that way. Again, big things to remember. Hopefully this is going to help you with your summary is that remember, it depends on what you are perpendicular to. If you are perpendicular to the y-axis, use y variables here. But again, still works all very much the same as what we've done before. Hopefully that helps. If you have any questions, please feel free to let me know.